All right, so it's, as we're reading along, right? So, I just made these slides a couple weeks ago because I thought we needed to get in a little harder example before we start rolling onto non-determinism. The next slide was going to be non-determinism, but I've slipped in one more example before we do it. All right. So in this example, it's a much harder example. All right, and it's, does the string contain 0, 1, 0, 1? Right. It can be whatever. It's a 0, 1 string, but is there a substring where it goes 0, 1, 0, 1? Right. So what do we want to read as we read in so far? Right. We have to think, what do we want to remember? Right. And so that you never have to reread things. And so let's look at various examples. Here I've highlighted something interesting in red. Right. So if you've read that in, what do you want to remember? So the answer is yes, right? And more specifically, we want to remember, oops, that wasn't right. Come back. Oh, that was the button that I hate. Focus on states. There we are. Look at that. That wasn't so bad. Right? We're remembering that it's a definite yes, right, as he said. And how do we remember it? Remember it that we're standing on a state, right? So I got this little gnome from the internet, and he's our little guy who's going to go from state to state, right? And what state are we in? Here's a state. When we're in this state, we give the state a nice name, and the state's name is, it contains 0, 1, 0, 1, right? And as we've indicated, this is going to be a definite yes. Right? All right, so now let's, right? So I will stand here and the state name will tell me what I know, right? I'm standing here, what do I know? I know that it contains 0, 1, 0, 1. And why do you give them meaningful names? It tells me what I know when I'm in that state, right? All right, so if you haven't read a full 0, if you haven't read this full thing, then maybe some progress is made, right? So in this example, it doesn't contain a 0, 1, 0, 1. At least I think I deleted it, right? But you see that we've made some progress towards it, right? So what do we want to remember? Well, not that it's not good enough that it contains it. Because what happens if I had it back here? Right? That's not good. Having it over here doesn't help us. Right? It only helps us because maybe it'll turn into what we want. So what do we want to say? We can say here it ends in it. Right? Does that make sense? And then there we can say it ends in that. And there we can say it ends in that. Right? And here, well, it doesn't seem like we've done anything much useful. Right? Does that make sense? So here are the various states that you can imagine being useful. And one way I could have gotten them is by trying various strings like this and thought, what states do I want? Sometimes what I do is I start here and I say, I've made progress. Certainly if the string was 0, 1, 0, 1, I would want to say no progress. Oh, I got a 0. Oh, I got a 0, 1. Right? You can imagine those states. So you just kind of hack out to try to think of what states you have and what names you want to give them. Right? Now, you might notice that this one is centered because I like its name, and these ones aren't centered because I don't like their names. Right? What's wrong with these guys? Do we want to add some more extra information here? Well, let's try. What happens if this is my input? Right? Not my full input. What happens if this is what I've read so far? Right? A deterministic finite automata is deterministic, which means every step, what it does is fixed. right? As opposed to non-determinism where it's not fixed, right? But here it's fixed. So given this, if we've read this so far, we're supposed to be in one state. There's one state that we're in, right? And so which state should we be in? We want to be in this state, right? But this here claims that we're in this state, right? So we need to change this guy's name. How are we going to change the name? Yeah, exactly, right? Right? We don't want two guys, right? The computation can't be in two places at the same time, right? For any two states. So another way I think about a state is I think about the set of strings that will end up there, right? I mean, this in some ways, the way I write it, it's describing a string, right? A set of strings. The set of strings that will land here is the set of strings that contain 0101, right? And what strings will end up here? Well, if they end in this, and they don't contain, right? Yeah. These guys? Oh, well, we're not allowed to. The reason we have two is to show you that we're not allowed to, and we got oops there, right? So here, if we said where do we want to be when we're in this, if we've read this so far, and it looks like, well, we could be here because it has that property, and we could be here because it has that property, and that's bad, right? Yeah. Yeah, all of these are good. Yeah, we're going to have a lot of those problems. Yeah.
I'm just wondering why when we first read the 0101, we didn't just go into a yes state and go all through.
Do I got a 0101 here? Yeah. Exactly.
Why does it keep going? Why didn't we just go through all the yeses because we know that it contains it?
The rules of a DFA is you got to read the whole thing in, and then accept at the end of the string. All right, but we're all agreeing that if we've read this so much, we're supposed to be here, right? And so so these sets, the set of strings that are allowed to be here, must be disjoint from each other, right? This string can't both end up here and end up here. So we have to make these sets disjoint. So what are we going to remember? We're going to remember that one. And so in all of these cases, right, it doesn't contain what we're looking for. Right? Everybody buy that? And I think our light blue man over there might have been hinting at this extra thing. Are these sets disjoint now? Right? What about, see, what do we got? We got some, I think, all right, so that string, right? Look at that string, ends in a 0 and ends in a 010, right? So that's not disjoint. So we can throw in here, right? It doesn't end in that, right? And then you kind of think, are they disjoint now? Oh, what about this one? No progress. Well, we got to say it doesn't end in one of those things, right? And now I think they're disjoint, right? Yeah? This one here? Contains. The last one, right? Farthest, it's this one. Yeah, in the middle. Yeah. They're disjoint from each other because that's a knot. Yeah. Sorry, that's a knot. Right. So I work to make them disjoint. Right. Everybody agree with that? Well, it means that it doesn't contain 010, it doesn't end in a 0, and it doesn't end in a 01. All strings of that form. Right? What we call it no progress because we haven't made any progress. Right? Everybody follow these states? All right, so now, right, and you can play with it and convince yourself that any two of these are disjoint. Right? And then we have to, now we know what the states are, so we have to say, how do we establish the loop invariant? Which state are we in first? For the empty string. No progress, right? If no characters have been read, what state I'm in that state, right? So here's my little arrow telling me that that's the start state, right? Does that make sense? And then, now we need to maintain the loop. Suppose I'm in this state and I get a 0. What state do I go into? Right? Because if I've made no progress, any string here, any string that's a no progress string, if I get a 0, I know it ends in 0. Right? And if I get a 1, still no progress. Right? That 1 wasn't useful. People buy that? And if here I know it's ending in a 0, if I get another 0, then it's ending in 0, 0. What does that bring me? It still ends in a 0. I'm tempted to say, uh-oh, 0, 0 is no good, so we've made no progress. Right? Oh, no, but it still ends in a 0. Right? People buy that? All right, if we get a 1, oh, we're nicely over there. Just like we would hope. Yeah?
Why didn't we go first time for 1 table?
Oh, because it would have, because it doesn't end in a 0. So here we have something that doesn't end in a 0, and it gets a 1. So we can't go there. There's nowhere we can go, right? In fact, if it ends in a 0 and we get a 1, then it ends in a 0, 1, and that's here. It doesn't end in a 0, 1, but I don't know.
Just because we read 0, we were at no progress, we read a 0, we went to end 0, and then we read a 1. So why didn't we just go to end 0, 1? Because then it didn't end in 0, 1.
Because the one we read is a no progress.
Input was 1. Oh, okay.
Right? So if we have some string that's a no progress string, and we get a 0, if we get a 0, we move over there. But if we get a 1, we have to argue something that this is no progress, right? And it's probably because this is not a 0, so this is either nothing or it's a 1. And if we have 2 1s in a row, that's no good. All right, so here we get a 0, we go over there. But if we get a 1, now we go all the way back to no progress, right? Because then we got a 0, 1, 1. And if we get a 0, we go all the way back again because we got a 2. Oh, is that right? Oh, that's wrong, guys. We got a typo here. It should go here, right? So much for me making slides at the last minute, right? That should go here. And then if you get a 1, you go forward. And if you're here, then you just self-loop, right? Everybody buy that? And, all right, so now we need to get the post condition, yeah?
Just to clarify, so when you're making and designing all of these states, the main idea is to create the final state you want and then exclude states as you go, right? So that's what we did here.
Yeah, I'm not going to go that as a general principle. In fact, if anything, I start with little examples moving forward, or you could, I often want to leap into the middle of the computation and think, well, what are the various things that I might want to remember? I'm trying as I teach this over and over again to get better methods for you to solve these, but I don't have a really good method yet for what the states should be. We're just sort of making it up here. Now, once you have the states, we're filling in the edges.
Like, for example, if we were to jump, let's say we just have a bunch of fruit, right, and we're in a market, and we just want to know what fruit we're at the market, we can just say, if it's a banana, if it's a banana, if it's not an orange, if it's not an apple.
Right.
The other one would be like, if
Yeah.
it's an apple, it's not an orange, and it's not a banana,
Yeah.
therefore it's an apple.
Yeah.
It's just that, right?
Yeah. we're going to build a number of these, and let's see if we can, as we get the pattern of it, I like to learn not just, we want to learn how to build these things. And if anybody has any more insights on how to teach how to build them, let's make slides for it, right? When I think of how do I build this, I probably would have built them in this order because, I think of the example. I might start by running examples, right? Suppose my input is 0, 1, 0. Then I can think about what is that example going to do, right? It's going to start here, and then it's going to go here, 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 right? So that builds, right there I built a certain amount of my machine, right? And then I start to think, oh, but what happens if I have a different string? Yeah? Yeah.
Right? And then you just keep looping.
Yeah.
Then why do you need the other states to have does not contain 0, 1, 0?
Because these, so the names have no use to this machine, right? The names are just for our own benefit. So the machine has these states and these arrows. So, but why do I have these names is I'm trying to give you meaningful names. And the meaningful name, I want to say, what do I know when I'm there? Right? When I'm here, I know it contains. Well, so when I'm here, what do I know? Well, I know it ends in 0, 1, 0, but I also know that it's not that, because if it was that, I would be over there. Right?
So is it really necessary to write does not contain 0, 1, 0? Because if you're in this state, you know that you...
Well, there's different levels of necessary, right? There's I want to build the machine so that it needs the certain states and the certain arrows, and you want it to work. To get it to work, you don't need this necessarily, right? But if you want to give it a meaningful name, then you need. How meaningful of a name do you want? If you gave it just that, then as a marker, I might complain that your sets aren't disjoint, but I would know what you meant, right? So it depends on what level of what you want here, yeah?
So when the ends in 0, 1, no, should it also say it does not contain 0, 1, 0? Like the one just to the right of it.
This one here?
Like for the ends in 0, 0, 1.
0, 1, 0 here? This one? This one? This one.
One in the middle, yeah. Like, shouldn't I also say just inside of it? It should say does not contain 0, 1, 0.
Well, if it could contain 0, 1, 0, right? So if my string was 0, 1, 0, 1, 0, right? Now it contains this, but it's not helpful, right? All right, we're going to build a bunch of these, all right? Now, at the last step is to say which states you accept, right? And in this case, we only accept the last one, right? Does that make sense? And that's our DFA, all right? So certainly one task of this course is to build DFAs, right? And now